Hello, good morning, good afternoon, and welcome. I'm very pleased to be joined by Martin West. Martin's a principal engineer at TfL, which is the Transport for London, which is the authority which sort of is responsible for running the huge transport system and the excellent transport system that London benefits from, and especially the huge fleet of buses which are actually owned by, I think, private companies, but TfL sort of sets the standards and I guess regulates in that respect. So welcome, Martin. Thank you for joining me.
Thank you.
Thank you. So you're going to be speaking at the upcoming World Hydrogen UK event, which is, I think, 9th and 10th of April. You're obviously going to be speaking around the mobility function, and you've been trialing hydrogen buses and implementing a quite successful zero emission strategy, or I guess the first phase of the zero emission strategy for the bus fleet. You've got I think over 1,000 battery electric buses and some hydrogen buses. So can you maybe just sort of give an overall picture of the zero emission strategy, both on the battery electrics and now the hydrogen, and maybe delve into a bit of the sort of performance issues or challenges that and learnings that you've taken away from the first couple of years of your zero emissions strategy?
Certainly, yeah. So where to begin? So we've been on this path now for a few years. I think since 2020 we've been only buying zero emission buses. I've been single deck and obviously double deck buses. Double deck buses are very important to London in particular. Obviously, they're quite a challenging vehicle type to have a zero emission solution for, because you can't put loads of extra equipment, whether that be hydrogen tanks or batteries, on the roof of a double deck vehicle. We've been very successful now, and as you pointed out, we've got well over 1,000 zero emission buses. And our policy is very much just that. It is for zero emission buses, so it's not technology specific to battery electric or fuel cell or other solutions such as opportunity charging, which we are looking to do some trials and get some experience of as well. And we have an ambitious target by minimum 2034 to completely remove all diesel and diesel hybrid vehicles from our fleet. However, we do have ambitions to accelerate that further, potentially 2032 or 2030, depending on a number of conditions being met, certainly on that. But we're doing very well now. We have 8,700 vehicles, so we're good, well over sort of 10%, 10-15% way there now. It's quite mixed. We have some operators in London which are very, very large, and some that are very small, just have a single depot facility. And yeah, some operators have gained a lot of knowledge and experience when it comes to deploying zero emission vehicles. We have our 20 hydrogen fuel cell buses, double deck buses, at one of our operators, Metline, in West London, for the fueling facility on their premises as well. So yeah, learning a lot along the way. Some challenges at particular locations, getting grid power to some sites and facilities. Grid is becoming quite constrained in particular areas of London, particularly West London. Seems to be a very constrained area for power. Lots of data centres sort of popped up during COVID, apparently, which has gobbled up power, along with electric bus garages, for that matter as well. But yeah, we're certainly working quite closely with all of our operators on their zero emission plans and supporting them to accelerate them as rapidly as possible.
And in terms of the challenges around the hydrogen fleet, or the 20 odd buses that your operator has, is there anything around the performance of the buses? I mean, I think you had different generations of hydrogen fuel cells, as we were speaking earlier. And what's the sort of performance like in terms of the actual bus?
Yeah, so right. So this is our 4th generation of fuel cell bus that we're on now. Obviously, we've gone from the 1st generation being very experimental prototype kind of generation of bus does a fuel cell in a vehicle work kind of concept, through to a product that we've got that is more or less sort of commercially and market ready. So it's a double deck bus, and it seamlessly integrates into the bus garage. So, for example, the maintenance facility that our hydrogen fuel cell buses are maintained at is the exact same depot that the diesel buses are maintained at, and the diesel hybrid buses are maintained side by side using the same facilities with some, sensible modifications to the vehicle, to the facility to make it reasonably practical. However, the cost was minimal compared to some of the mitigations that we had to make for the earlier vehicles that came along, because it was simply, it was all very new and very unknown. In terms of the performance of the vehicles themselves, there have been some blips along the road, but certainly they are, from a vehicle standpoint, operating very well. The fuel cells are operating very reliably. The fuel consumption is down, averages somewhere between 6 and 7 kilograms per every 100 kilometers that the vehicle travels, and previous generation of vehicles was around about 9. So we are seeing a step change in performance there, and it's certainly well within what our expectations of the vehicle are. Daily range is around 250 miles the vehicle is capable of. There is some additional capacity within the vehicle if we wanted to put an extra set of tanks if we needed it, but we didn't. So certainly we're not range constrained by the vehicle at all. And one of the really good things about the bus is we don't see much variability in that range throughout, the ambient conditions of temperature fluctuations and things like that. Waste heat from the fuel cell is used to supplement the heat that's saloon into the rather than drawing more energy from the vehicle to pump into the vehicle for heat, like the battery electric vehicles, of course, have to do. So that that is an added bonus that we don't see that variability. Fueling times are very good for the vehicle, around about 5 minutes.
And I guess you're inferring that there is quite a range on the or a change in the range of the battery electric buses throughout the year, due, I assume, to sort of lower temperatures in winter impacting the range.
Yeah, that is right. I mean, all of the energy for the passenger saloon and for the driver to demist the windscreen and to keep the driver in ultimately has to come from the batteries on a battery electric vehicle. There is no, it's obviously the drive drying is obviously much more energy efficient from a well-to-wheel perspective. However, you don't have the added bonus in of waste heat, which on a fuel cell bus isn't. Well, it's waste heat during the summer, but in the winter that waste heat is useful heat. You don't have that, so the energy has to come from the batteries. So, and then depending on where the temperature curve is, the buses use a heat pump, because obviously that's the most efficient way of using heat. But obviously heat pumps only work particularly well down to sort of single figures. Once you get to sort of 5 or below, then heat pump loses a lot of its efficiency. Then they have to supplement that heat with.
That's 5 degrees temperature.
Yeah, sort of 5 degrees and sort of below, the performance of heat pumps starts to sort of drop off. The performance curve starts to sort of curve downwards, and then we sort of have to the manufacturer to sort of supplement that heat with more sort of traditional forms of heating, which are more energy intensive, which really starts to hit the batteries of vehicles. But mitigations can be put in place by the operator to factor that in. Obviously, they can do en route charging, or they can bring the buses back to the garage. They can put allowances within the duty cycle of the vehicle to try and get supplementary energy into that vehicle during the day, or they can buy a bigger bus with a bigger battery to cater for that need. But obviously, there obviously is additional costs of bigger batteries in, or there's operational benefit that needs to be factored in to that operation as well. So
Because I mean, buses are on the road. Sorry, buses are on the road for, I assume, a long time in terms of sort of maximizing the asset. They're I suppose it was, I don't know, two shifts, as it were, sort of 16 hours or something. Or
Yeah, so I mean the average duty cycle of a bus is 18 hours on
Right.
average, but that's the average. We have quite a lot of buses that will go longer than that, and then of course some shorter than that as well. So there is quite a lot of variability within the bus fleet, and of course some of them operate more or less 24/7 on the 24-hour routes, and we do have quite a few of as well. So there's quite a spectrum of duty cycle needs within London, and of course we want to make decarbonise as quickly as we possibly can, and make sure that we can deliver as much benefit as quickly as we possibly can. So we tend to do the operation, we'll do the routes which we can get most benefit as quickly as we can, which tend to be the lighter duty stuff, and the more challenging operational duty cycle will naturally come later in the strategy, hopefully as technology further develops, that better solutions become available to meet the more challenging needs of those routes. But obviously, by 2034, whenever it is, if it is pulled closer, we'll have to the operators will have to make a decision on what technology they're going to deploy, and then what mitigations they're going to have to put in place to enable that full conversion to zero emission to take place.
Yeah. And can you see a scenario when they would adopt two technologies, or you think it's likely just to coalesce around one sort of technology?
I think there certainly is potential for sort of two technologies, but whether it's two technologies operating from the same facility is an interesting question. Do you have a hydrogen fueling station on site as well as having battery electric vehicles, or do you just
Yeah.
hydrogen sort of scales quite well? Do you just go, well, if I'm going to put in a hydrogen fueling station anyway, might as well serve all of the buses there with it. That's philosophy that I think people are considering. Obviously, you might have this benefit if one of the main reasons that you're looking at hydrogen is because you can't get sufficient enough power to your site, then it might make sense to do a lot
Yeah.
hydrogen.
And in terms of up until now, I mean, hydrogen, the fuel supply, have you had issues with fuel supply?
Yeah, well, certainly our third generation, our demonstration of buses that we had on RB1, we had operated for nearly 10 years, went across Tower Bridge. You might have noticed some single deck buses on that operating for 10 years. The fuel supply was very reliable, very stable. The buses were still early sort of prototype kind of vehicles. The buses were probably more problematic, but the fuel supply was very reliable. Unfortunately, on the successor to that project, which is Jive, which we're on now, fortunately we've got sort of the reverse happen. The buses are, more or less very reliable and performing very well. However, the fuel supply has been somewhat unstable, I would say. So we're not doing on-site generation. We've got a delivered model. Obviously, footprint is very valuable in London, so obviously we need to minimise the footprint of our station as much as possible. So we have a delivered solution using tube trailers, and trailers filled up elsewhere in the UK. And I don't know if it's a combination of factors between the energy crisis and obviously the significant uptick in the demand for hydrogen for all various different applications that you could possibly think of. Sort of the existing supply capacity within the UK was already fairly, should we say, at limit, because
Yeah.
it takes one thing to go wrong in the sort of the UK supply chain of one facility going out,
Yeah.
and those customers trying to fight over the remaining spare capacity. Somebody's ultimately going to lose out, and that has led to quite a few supply disruptions.
Yeah. Yeah, definitely. Well, hopefully hopefully our Congress and the development of the industry is going to alleviate that in terms of fuel supply. But certainly, thanks for sharing your thoughts with us. It's fascinating to hear some of the realities on the ground between the two technologies in terms of the movement. Also impressive to see over 1,000 zero emission buses in the fleet of London, and obviously still got another, I think it was a 7,000, 8,000 in total, so it's another 7,000 to go. But I assume come 2034, there'll be a lot. London will begin to feel a lot better, a lot more cleaner, I guess, in terms of the end of diesel smog. So looking forward to that, and looking forward to the Congress, looking forward to you taking part, Martin. So thanks a lot for taking time out your day today. It was great chatting to you, and we look forward to seeing you at the event come April.
Thank you very much. Yeah, looking forward to
Cheers.
meeting you. Thank you.
Excellent. Take care. Bye bye.